Alright boys and girls, it has finally arrived. So after around 3 months of waiting, all the way since the original launch of the new 10th gen Core series CPUs from Intel, the EVGA Z490 Dark is finally making its way to the retail market. So this is the motherboard which many of you have been asking questions about, many of you have been waiting for, but the board is finally ready for retail sales. There were some issues along the way, but they have been fixed for the most part now, and the board should be available for purchase next week or so. So on this video, let's take a quick look at the board itself, so do an unboxing and overview, and then we can make a separate BIOS overview video later with overclocking tests and so on, and not to integrate everything in the same video so that the video doesn't end up being ridiculously long, like how it happened with the Z390 Dark like 1.5 years ago. But yeah, so Z490 Dark, it's meant to be the flagship motherboard model for the new mainstream 10th gen Core series CPUs from Intel with the Z490 chipset. So this is meant to be the highest option what EVGA can offer, and to compete against the top motherboard models from other vendors or so. So I think the most ideal CPU for this particular motherboard model will be the new 10-core 10900K, because obviously this board isn't like the cheapest Z490 motherboard you can find on the market. So I would assume that most of you who will be getting this board will be getting the new 10900K. But obviously all of those CPU models, so even the lower end models, will work just fine on this board as well. But yeah, so very simple packaging, just like the Z390 Dark, and on the X299 Dark boards we have only the main features advertised on the packaging itself. So we have the full model number stated over here at the bottom left corner of the front side of the packaging with a QR code. Then main features are listed over here. So this is Intel chipset Z490, supports new 10th gen Core series CPUs from Intel. It is Intel Optane ready and supports NVIDIA SLI. Of course, SLI and multi-GPU configurations have changed a lot over the years. So nowadays it's mostly about like 1 or 2 cards. 3-way and 4-way aren't really supported anymore, even for benchmarking purposes. So for example, 4-way kind of died with the GTX 1080 Ti. I think 1080 Ti is the last graphics card model from NVIDIA which can run in 4-way, but of course it doesn't run like efficiently in 4-way in like normal use, only for like test programs like 3D Mark and so on. But if we take a look at the back side of the board, we can see, well, nothing pretty much. So we can see USB 3.2 Gen 2 ready, 2-way SLI with NVIDIA PhysX. So new Elite X1 overclocking software, they kind of improved the overclocking software for their motherboards, because all the way until now the overclocking software, so the Elite, has been kind of bad. If you ask me, there have been numerous bugs with the software. At first it didn't work well in all operating systems, and it wasn't kind of like reliable overall. But now they have a brand new Elite X1 for this particular motherboard model, and so far when I've been using it, it works really well. And yeah, just EVGA warranty mentioned. So if you are familiar with EVGA products, they have awesome warranty policies. So if you get any trouble with your purchased product, you can handle the situation straight with EVGA themselves, so you don't have to contact the actual store from which you bought the product originally. You can discuss the warranty-related things straight with EVGA, and you can send the faulty graphics card or the motherboard to the EVGA guys themselves, and they will send you a new one. So it's really awesome compared to many other computer component manufacturers, if you ask me. But yeah, so let's get this box opened up and let's see what it comes with. I actually haven't opened up this board yet myself at all, so it will be interesting to see what the board actually comes with, but it should be pretty much the same as the Z390 Dark, because it looks so much like the Z390 Dark. But there haven't been that much information about this board yet, only some short peak articles back when the new Comet Lake CPUs were coming out to the market, and obviously my 5.5 GHz CD bench run, which I made around 3 months ago with this same motherboard model. Only that it was an engineering sample version, but it's pretty much the same. So this board is definitely good for overclocking the CPU and the memory on the new Comet Lake CPUs. But yeah, so let's get this thing opened up. So here is the box itself. Oh, so yeah, it's missing all the accessories, but it doesn't really matter. We just want to see the board itself. So I would assume it comes with most of the accessories you got with the Z390 Dark. If you are familiar with the board, they only gave me this PCB guide / test bench, so you can use this as a guide to see all the features on the board, locate all the different components and so on. But yeah, so no accessories for me this time, but doesn't really matter. We can still take a look at the board itself. Alright, so that's how the Z490 Dark looks like in a first proper view on YouTube. As we didn't get any of the accessories of the retail packaging apart from that motherboard guide plate, which also works as a base plate for a test bench, I think we can go straight to the motherboard itself, because that's what we are mostly interested in. So at first glance, the Z490 Dark looks pretty much the same as the previous Z390 Dark for the Coffee Lake CPUs. We have the same heatsink design on the motherboard, so we have this huge heatsink combination for the VRMs and for the Z490 chipset, and I think these heatsinks should fit the Z390 Dark and vice versa. So I'm pretty sure I should be able to fit the heatsinks of my Z390 Dark on my Z490 Dark beta version, because at the moment it doesn't have any heatsinks at all, but just saying. Then the most notable visual feature on this board is definitely the rotated socket. So just like on the Z390 Dark and on the SR3 Dark, the entire LGA 1200 socket, the VRMs and the DDR4 memory slots themselves, they are rotated 90 degrees counterclockwise. So the motherboard looks almost like an LGA 775 motherboard from 12 years ago. EVGA advertises that it should help with the actual cooling performance, so when you have fresh air coming from the front part of the case, it should be able to go through or over the socket area when the socket is rotated counterclockwise like this. I'm not fully sure about the actual cooling performance, but I really just think that it looks cool and unique, like something different on the market. And then the Dark motherboard models, they don't have any RGB lights on them. And that's also a feature. It could be a minus to some users, but you can always add RGB lights yourself afterwards. But just out of the box or by default, the Dark boards don't have any RGB lights on them. So when we go through the rest of the motherboard's features, we can see that there are 3 full-length PCI Express X16 3.0 ports. All of these full-length ones, they are coming out directly from the CPU itself, and each of the slots and ports, they are labeled so that you will know how they will run when there's a device attached to them. So the first slot will be, the first PCI Express slot is X16 or X8, the second one is X8 or X4, and the bottom one is PCI Express X4 slot coming out from the CPU. And this black PCI Express X4 slot is coming out directly from the Z490 chipset, and the full length ones are reinforced with that steel plating over there. So you can run two-way SLI or three-way Crossfire X on this board. So if you run a single card, like one 2080 Ti, you will install it in this top slot over here and it will run in X16. If you run two-way SLI, it will be X8 and X8. And if you run three-way Crossfire X, it will be X8, X4, X4. So that's how they will work. Then we have two full-length M.2 ports over here between the first and second PCI Express slot. They are full length, so you can install any M.2 device you wish into those two ports. I think with the retail packaging you should get those thermal pads once again, so you can install a thermal pad between the motherboard's PCB and the actual M.2 device, and then the entire motherboard's PCB will act as a huge heatsink for those M.2 devices, so that should help with the actual cooling performance on those M.2 devices. Then we can see that the audio part is separated once again as before, so we have this golden line going around over here that separates the audio part from the rest of the motherboard's PCB. So we have a 7.1 audio chip over here by Realtek and rest of the audio components over here. We have one 6-pin PCI Express power connector over here. So if you run 2 or 3 cards, you should install this supplementary 6-pin power connector over here. Then we have 2 RGB headers over here. So I think you can use these to control any other RGB lights in your entire system, because the board itself doesn't have any RGB lights. So, but I have never used this myself. Then we have many fan connectors on this board, and many of them are rotated 90 degrees if they are present at the edge of the motherboard's PCB. So that should help with the overall cable management, so you don't have to like route a cable coming out from like under the motherboard and then going over, coming down from like over the motherboard. So just it should help with the overall cable management when they are rotated like that. Then we have, I think this is unique to EVGA nowadays, so they still have this like BIOS or postcode speaker, so it will beep when the post process is done. Then we have 3 front panel USB headers for your case. We have the BIOS battery over here in its usual spot. Front panel connectors are over here, and then when we turn the motherboard over, we can see that there are 2 more fan connectors over here at this corner, and they are also rotated 90 degrees. We have 8 SATA 3 ports over here, 6 of which are coming directly from the Z490 chipset, so the bottom 6 over here, and the top 2 are coming out directly from a third-party Asmedia storage controller on the motherboard. So we can see that there are 4 white lines over here that separate the SATA ports from each other. So the top ones over here are coming out from this SATA, from this Asmedia SATA controller over here. And that third-party chip doesn't only like increase the amount of SATA devices you can run on this board or in your system, it also adds more like operating systems which you can run with this motherboard model. So the cool thing about Asmedia based SATA ports is that you can still run those ports in IDE mode. So if you install the SSD or the hard drive into these 2 SATA ports, you can still run Windows XP or Windows Server 2003 very easily when you run them in IDE mode. So you don't have to mess around with any unofficial like AHCI drivers if you had to run that old operating system from an Intel port. So that's why they are added. And then we have one U.2 port over here, and this one over here should be the USB 3.2 Type C port for the case. Then we have the front panel USB 3.0 port over here for your case. We have the 24 pin plus both of the 8 pins like grouped together over here, and they are all rotated 90 degrees with this cutout on the motherboard's PCB. So I think EVGA is the only motherboard manufacturer that has the CPU power connectors and the 24 pin at the same spot. It was the same on the Z390 Dark, the same on the Z490 Dark now, and the same on the SR3 Dark. So it's quite cool that they have all the power connectors in the same spot. So it makes the overall cable management like much better. On the X299 Dark, the CPU power connectors were still in the same spot, so at the top part of the motherboard's PCB. Then over here we have two more fan connectors over here. We have the BIOS selection switch. So the motherboard has 3 BIOS chips. So we have the first BIOS, or the main BIOS, in the top position. The second one is on the middle position, and the third one is on the lowest position. So the motherboard is very idiot proof when it has 3 BIOS chips. So it's very, very hard to completely brick this motherboard with failed BIOS flashes. So if you corrupt the main BIOS, you can switch to the second or third position and use that to recover the first corrupted BIOS. So that's very, very handy. And you can have different BIOS versions on each position. So for example, on the X299 Dark, I have 2 Skylake X BIOSes, and I have 1 Cascade Lake X only BIOS on one of the BIOS switch positions. So that's very, very handy if you ask me. And it doesn't add too much extra cost over just like 2 BIOSes or just 1 BIOS. So it's really nice to have 3 individual BIOSes on a motherboard. Then next to that we have the PCI Express disable switches. So, but funny, there are 5 switches, although there are only 4 PCI Express slots on this board. But those are only for troubleshooting. So if you have, let's say, 2 cards in SLI with water blocks on them, and suddenly one of the cards dies, and you don't know which one is giving you issues, you can troubleshoot the situation by turning off the slots individually and find out which of the devices is preventing you from posting. So it's very, very handy, and it has been around for a very long time now. Then next to that we have the slow mode switch for the CPU. That doesn't really have that much use in like normal real world use. It's only for extreme overclocking situations. So if you want to drop the CPU frequency down quickly, you can flip the slow mode switch and it will drop the CPU frequency to 800 megahertz. So the same thing as what the CPU would do if the CPU was overheating. So you can quickly put the CPU in slow mode, set your target frequency in, put the slow mode switch back to normal position, press F7 on your keyboard and use CPU-Z to validate your desired frequency, and then you can flip the CPU back to 800 megahertz just like that to save some heat. So that's mainly one of the only uses for this switch, but it's quite handy. Then on this part of the motherboard we have 2 more fan connectors, so the CPU fan connector plus the optional one. Then we have the power and reset buttons, and then we have 2 debug LEDs. And it's not just debug LED, it's also a monitoring device, which is unique to EVGA. So the right one of these LEDs is the postcode debug LED, and once the board has successfully posted and running, you can use those 2 debug LEDs as one monitoring device. So you can monitor different parts of the board. You can monitor the CPU die temperature, the VRM temperature, and different voltages on the motherboard, like Vcore, accurately, so at the hardware level, not inaccurately like the software does. So you can monitor Vcore, memory voltage, system agent, and many other options on the board. So it's very, very handy. So if you have a good case with a clear window, you can use that monitoring device to monitor. You can monitor the VRM temperature, for example, or you can monitor the actual Vcore accurately. So you don't have to use like a multimeter to separately check the real Vcore value at idle and under load to find out like what is the most suitable load line calibration setting for you. So that's very, very handy. Then we have 1 clear CMOS button over here. There are 2 present on these modern EVGA boards. So we have 1 over here and another one at the rear I/O. Then we have a safe boot button over here, so the black button over here. If you fail the post process, so let's say you post some settings successfully, then you make one change in the BIOS, like you tighten one memory setting too much and now it prevents from posting, so it doesn't post anymore. You can press the black button and it will load the previously worked settings, so you can revert the latest change and you can go back to the BIOS and change that setting back, and then you can post again. So it's very, very good way to get back up and running without clearing all the settings, like having to do a full CMOS clear. That's very, very handy thing to have over there. Then this this white USB port over here, that's your BIOS flashback port. So compared to like Asus or Gigabyte boards, the USB flashback port is located on the motherboard's PCB, like at this part of the board. So if you want to flash the BIOS without having a CPU or memory, you can do that by just having the standby power from your power supply. So you only have to plug in the 24-pin power connector over here, and you can flash the motherboard's BIOS. You have to download the desired BIOS file from EVGA.com. You have to put it in an empty FAT32 formatted USB drive, named correctly. So you have to check the real model number of your board. So for example, for this board it would be like EVGA E499.bin. So you have to name the BIOS file correctly, just like on Asus boards. Place the file in an empty FAT32 formatted USB drive and plug that in to this port over here. And then you have to press the reset buttons, the reset button 5 seconds. It will start the counter on this debug LED over here, and it will start the BIOS flashback procedure. So it's very, very handy. With some USB sticks it doesn't always work, so there are some compatibility issues. It didn't work for me on one of my USB sticks, but I changed to an older one, like USB 2.0 device, and then it worked. So it might not work like 100% on every USB stick out there, but just saying. So that's how you generally do it. It will start the system during the process, but you need at least 24-pin power to do that process. And then we have the DDR4 slots over here. So we only have 2 slots as before for the best possible overclocking performance. So the motherboard has single slot per channel design, which has more overclocking headroom than the standard 4-slot design or 2 slots per channel design. The most ideal memory for a high-end motherboard like this would definitely be like Samsung B-Die, and nowadays with what we have seen lately, you definitely want a very highly selected Samsung B-Die kit with A2 PCB. So A2 PCB is the latest PCB revision for the Samsung B-Die based memories, and the easiest way to recognize that is to notice these 2 tight stacks of 4 memory chips on one side of the memory stick's PCB. So the other side is empty, no chips at all, and on this other side the memory chips are in like 2 tight stacks of 4. In the first or original AO PCB, all of the memory chips are in one single line at the center of the PCB. This PCB type has better like frequency headroom, so you can run much higher daily frequencies, and you can also run like high frequency with good timings, but generally, most of the time you were always limited to common rate 2. But nowadays, and also on the Z490 Dark, the common rate 1 works much better than before. So now you can run common rate 1 at frequencies of like 4800 to even 5 GHz plus with CAS 14. So that's really, really good performance wise, and it destroys the old AO PCB totally. So this particular kit is 4800 CAS 19 kit from Galax, so 8 GB each. So these are a good example of memory type you would want to get on a high-end motherboard like this. So you want to get these and run 4600 or even 4700 plus with 17, 18, 18 in a daily situation, or like 4800 plus to 5 GHz plus with 14, 13, 13 timings with common rate 1. So that's the most desired memory configuration nowadays, for both for daily and for overclocking situations. Then we have the CPU socket itself, and on this part of the board's PCB we have the BIOS, the post LEDs over here. So if some device fails from posting, it will light up red over here. So we have like CPU LED, memory, VGA, boot device, and so on. Then we have two Pro-bit connector headers over here, so you can monitor each of the voltages on the board accurately with a multimeter, like Vcore, memory, system agent, VCCIO, and so on. Like you can use the Vcore measurement to find out the most ideal load line calibration setting. Then moving on to the back, so the rear I/O part of the motherboard we can see. So we have a PS2 combo port for PS2 mouse and keyboard. Sadly, there's no individual PS2 port for mouse and keyboard. So if you want to use both mouse and keyboard from PS2, you have to get a Y cable that splits the combo port into two individual PS2 ports, and that will work just fine. We have 6 USB 3.1 ports from the chipset itself, so 2 for 6, and we have the Wi-Fi antennas over here, one CMOS clear button once again, dual Ethernet, then we have a mini display board over here, and then we have USB 3.1 Type A and Type C. And these ones over here should be coming out from a third-party Asmedia USB controller on the motherboard's PCB. So this Type A port over here will be the only USB port that works in Windows XP environment. So if you have to get like screenshots out of your Windows XP installation, just plug the USB stick into this port over here and it will work just fine when you install the correct driver for that port. But just saying. And here's the 7.1 audio once again. And there's pretty much nothing at the back side of the motherboard. We can see that the memory slots are surface mount devices, so there are no pins coming through the motherboard's PCB. Or we still have a like small hole to install a thermal probe for the CPU over there, but otherwise it's very standard as before with the previous model. So yeah, so that's pretty much how it looks like. So I think now we could take the engineering sample version and compare it side by side with the retail one, so we can actually see like the VRMs and so on, because it's pretty much the same. There is no difference with the engineering sample compared to the retail version that's over here right now. Here's the engineering sample version of the Z490 Dark. This is the one I used for the 5.5 GHz R15 clip, which I posted on YouTube like 2 or 3 months ago. So, and this is the same CPU I used for the testing. That CPU is quite good. It can easily run 5.4 GHz in Citybench and other tests, but 5.5 is quite on the edge. So it requires, as it's not deleted, so the CPU is not deleted, it needs quite cool room temperature to pass that 5.5 GHz frequency. So the room temperature at the moment has to be like 19 or 20 degrees to pass that frequency with 1.39 volts. I will be doing a deleting video separately later, and then with delete I'm sure it will run 5.5 very easily. And I think if we even run like direct die, we could even try close to 5.6. So the board is definitely capable of getting extremely high CPU frequencies even on water cooling, and now it's very good for memory overclocking as well. But so let's take a look at the VRMs. So the VRM structure is pretty much the same how it was on the Z390 Dark. So we have 16 power phases in total. So we have the VCCIO over here is the first one, and the last one is VCCSA. 2 of these intersil phases over here, so the first 2, or well, number 2 and 3rd, if you count from the inductors, these are for the iGPU. Then we have a doubled 6-phase for the CPU's Vcore VRM. So we have 12 phases for the CPU Vcore. So and those power phases are 60 amps each. So they are very strong power phases for the CPU itself. I'm sure Buildzoid will make a separate VRM analysis of the Z490 Dark as well, but you can watch his Z390 Dark VRM analysis video and you will get a very good like in-depth idea of how good the VRM is on these boards. But I was able to run the Z490 Dark with naked VRM with the CPU on LN2 at 6.7 or 6.8 gigahertz. So there was only just fan blowing towards the VRM area, and I had the Inferno backplate on the backside of the motherboard, so the VRMs themselves weren't getting like frozen from the cold temperatures of the LN2. So the VRM is definitely capable of running like very high frequencies on the CPU. I really like the design. But yeah, so the only accessory we got with this board was the motherboard guide plate. So it's only to show different features on the board, and it does work as a base plate for a test bench. So if you want to test the motherboard and other parts outside a case, you can mount the motherboard with standoffs on top of this plate. So here's how it looks like. So it's pretty much the same PCB as the board itself, and you can see all the different parts on the board itself. So we have the actual phases listed, that what part they use. So we have VSA, so system agent, Vcore, iGPU is stated over here, so VGT, 2 phases, VCCIO, 1 phase, Vcore, 12 phases. So that's very good way of like showing all different parts of the board. So and the PCI Express slots, CPU, and CPU. So, and you just need to put the standoffs on the ADX mounting holes, and you can place the motherboard on top of this and use the board outside a case. But yeah, so that's pretty much it. So I'm not fully sure about the overall availability of this board and the actual price of the board, but it should be getting listed next week. So if you live in the USA, go to EVGA.com. If you live in Europe, go to EU.evga.com, and you should be able to find the Z490 Dark for purchase at the beginning of next week or very, very soon. So I'm not fully sure like how many boards there will be overall, but so far, based on current information, the next gen Intel, so the Z590, should also be based on the same LGA 1200 socket. So the Z490 Dark should make like a good base practice for the next gen CPUs as well. But yeah, so if you like to see the Z490 Dark finally in a proper view, definitely give a thumbs up and subscribe to my channel. But other than that, thanks for watching once again, and I will see you on the next one.